Determine the specific electrical requirements with the homeowner, including power needs for the modular house, detached garage, and steel building. Assess the distance from the power pole to the house and determine the required underground conduit size and length. Consider consulting with a licensed electrician to ensure compliance with local codes and safety standards. Obtain a permit from the local authorities if required. Gather necessary materials such as underground conduit, wire, service entrance equipment, and safety gear. Determine the appropriate wire gauge and conduit schedule based on the power requirements and code regulations. Use the homeowner's backhoe to excavate a trench deep enough to bury the conduit according to code requirements. Install the conduit and secure it properly using conduit supports. Install the service entrance equipment, including the meter socket, main breaker, and ground rod. Size the main breaker according to the total load demand. Install electrical panels in the modular house, garage, and steel building. Size the panels and circuit breakers based on the electrical demands of each structure. Run wires from the service entrance equipment to the electrical panels. Install proper connections, terminations, and grounding. Use appropriate wire nuts and electrical tape to secure connections. Request an electrical inspection by the local authorities to ensure compliance with codes and safety standards. Obtain a certificate of occupancy before the structures are occupied. If you decide to charge an hourly wage, determine a reasonable rate based on your experience in the market. Consider the cost of materials and equipment as well as overhead expenses. Provide a clear invoice to the homeowner outlining the work performed, materials used, and labor charges. Prioritize safety throughout the project. Use high-quality materials and workmanship. Keep accurate documentation of the work performed. Communicate regularly with the homeowner to keep them informed of progress and any potential issues. Seek assistance from a licensed electrician if you encounter any complexities or uncertainties during the process. When running electrical wiring, remember that the National Electrical Code, or NEC, provides specific guidelines for safe and effective installations. For example, NEC Article 310.15 addresses the ampacity of conductors, which is the maximum current, in amps, a conductor can carry continuously under the conditions of use without exceeding its temperature rating. It's crucial to select the correct wire gauge based on the load it will carry to prevent overheating and potential fire hazards. The NEC also specifies requirements for conduit fill, ensuring that you don't overcrowd conduits, which can lead to heat buildup and insulation damage. Additionally, grounding and bonding are critical for safety. A proper grounding system provides a low impedance path for fault currents, allowing overcurrent protection devices, such as circuit breakers, to quickly trip and energize the circuit. Bonding ensures that all metallic parts of the electrical system are at the same electrical potential, reducing the risk of electric shock. For underground installations, NEC Article 300.5 provides requirements for minimum burial depths, which vary depending on the voltage and type of wiring method. For example, direct burial cables typically require a greater burial depth than conduits containing conductors. Service entrance equipment must comply with NEC Article 230, which covers the requirements for service conductors, overcurrent protection, and grounding. The service disconnect must be readily accessible and capable of disconnecting all ungrounded conductors from the premises wiring. Electrical panels must be properly sized to accommodate the anticipated load. The NEC provides guidelines for calculating the load demand based on the square footage of the building and the types of appliances and equipment that will be used. It's also important to select the correct type of circuit breakers for each circuit, ensuring that they are rated for the voltage and amperage of the circuit. When installing electrical panels, ensure that they are securely mounted and properly grounded. The NEC requires that all unused openings in electrical boxes and panels be closed to prevent the entry of dust, moisture, and foreign objects. Wire connections must be made using approved methods such as wire nuts or crimp connectors. The NEC specifies the types of connectors that are suitable for different applications. It's important to follow the manufacturer's instructions when making wire connections to ensure a secure and reliable connection. Electrical tape should be used to insulate wire connections and provide additional protection against moisture and corrosion. The NEC requires that electrical tape be listed and labeled for the intended use. Electrical inspections are an essential part of the process to ensure that the installation complies with all applicable codes and standards. The inspector will typically review the wiring, grounding, and overcurrent protection to ensure that they are installed correctly and safely. A certificate of occupancy is typically required before the structures can be occupied. This certificate indicates that the electrical installation has been inspected and approved by the local authorities. Charging an hourly wage is a common practice for electrical work. A reasonable rate will depend on your experience, the local market, and the complexity of the project. Be sure to consider the cost of materials and equipment when determining your hourly rate. Provide a clear and detailed invoice to the homeowner outlining the work performed, materials used, and labor charges. This will help to avoid any misunderstandings and ensure that you are paid fairly for your work. Safety should always be a top priority when working with electricity. Be sure to wear appropriate personal protective equipment, such as safety glasses, gloves, and insulated boots. Always de-energize circuits before working on them and use a voltage tester to verify that the circuit is de-energized. If you are not comfortable working on a particular electrical task, seek assistance from a licensed electrician. High-quality materials and workmanship are essential for a safe and reliable electrical installation. Use only listed and labeled products and follow the manufacturer's instructions carefully. Keep accurate documentation of the work performed, including wiring diagrams, panel schedules, and inspection reports. This documentation will be helpful for future maintenance and troubleshooting. Communicate regularly with the homeowner to keep them informed of progress and any potential issues. This will help to build trust and ensure that the project is completed to their satisfaction. Remember that electrical work can be dangerous if not performed correctly. If you encounter any complexities or uncertainties during the process, seek assistance from a licensed electrician. Consider the load calculations for each building, modular home, garage, and steel building. The NEC, specifically Article 220, provides detailed methods for calculating branch circuit, feeder, and service loads. For a modular home, start with the general lighting load, which is typically calculated based on the square footage of the dwelling. Add to this the loads for small appliance circuits, laundry circuits, and any specific appliances such as ranges, dryers, and air conditioners. For a detached garage, assess the lighting and receptacle needs, as well as any specific equipment like power tools or welders. For a steel building, consider the lighting requirements, receptacle outlets for general use, and any heavy machinery or equipment that will be operating in the building. Be sure to account for the non-coincident loads, which are loads that are unlikely to be used simultaneously. For example, it's unlikely that all the lights, appliances, and equipment in the modular home will be operating at full capacity at the same time. The NEC allows for demand factors to be applied to these loads, which can reduce the overall service size. When selecting the wire gauge for the service entrance and feeders, refer to NEC Table 310.16, which provides the ampacity of conductors based on their size, insulation type, and ambient temperature. Be sure to select a wire gauge that is large enough to carry the calculated load without exceeding its ampacity. The underground conduit must be sized according to NEC Chapter 9, which provides the dimensions and fill requirements for various types of conduits. The conduit must be large enough to accommodate the conductors and any necessary pulling lubricants. When installing the service entrance equipment, be sure to follow the manufacturer's instructions and the requirements of NEC Article 230. The meter socket must be securely mounted and properly grounded. The main breaker must be sized according to the calculated load demand and must be readily accessible. The ground rod must be installed in accordance with NEC Article 250 and must be driven into the ground to a depth of at least 8 feet. When installing electrical panels, be sure to label each circuit breaker with a clear and concise description of the load it serves. This will make it easier to identify and troubleshoot circuits in the future. Use appropriate wire nuts or crimp connectors to make wire connections. Be sure to tighten the connections securely to prevent loose connections and overheating. Electrical tape should be used to insulate wire connections and provide additional protection against moisture and corrosion. The NEC requires that electrical tape be listed and labeled for the intended use. When requesting an electrical inspection, be prepared to provide the inspector with all necessary documentation, including wiring diagrams, panel schedules, and load calculations. The inspector will typically review the installation to ensure that it complies with all applicable codes and standards. Remember that electrical work can be dangerous if not performed correctly. If you are not comfortable working on a particular electrical task, seek assistance from a licensed electrician. Be sure to prioritize safety throughout the project and use high-quality materials and workmanship. Always refer to the latest edition of the National Electrical Code and consult with local authorities to ensure compliance with all applicable codes and standards. Calculating voltage drop is a very important part of electrical design to ensure the proper voltage levels at the point of utilization. Excessive voltage drop can cause lights to dim, motors to run slowly, and equipment to malfunction. The NEC recommends the voltage drop on branch circuits should not exceed 3% and the total voltage drop on feeders and branch circuits combined should not exceed 5%. The formula for calculating voltage drop depends on whether the circuit is single-phase or three-phase, the length of the circuit, the current flowing through the circuit, and the impedance of the conductors. For single-phase circuits, the voltage drop can be calculated using the following formula: voltage drop equals 2 times the current times the length of the circuit times the impedance of the conductors divided by 1000. For three-phase circuits, the voltage drop can be calculated using the following formula: voltage drop equals the square root of 3 times the current times the length of the circuit times the impedance of the conductors divided by 1000. The impedance of the conductors can be found in NEC Chapter 9, Table 8, which provides the impedance values for various sizes and types of conductors. Once you have calculated the voltage drop, compare it to the recommended limits to ensure that it is within acceptable range. If the voltage drop exceeds the limits, you will need to increase the size of the conductors or shorten the length of the circuit. For example, consider a 120-volt single-phase circuit that is 200 feet long and carries a current of 15 amps. The conductors are number 12 American wire gauge copper conductors with an impedance of 1.98 ohms per 1000 feet. Using the formula for single-phase circuits, the voltage drop is calculated as follows: voltage drop equals 2 times 15 amps times 200 feet times 1.98 ohms per 1000 feet divided by 1000, which equals 11.88 volts. The percentage voltage drop is calculated as follows: percentage voltage drop equals the voltage drop divided by the source voltage times 100. Percentage voltage drop equals 11.88 volts divided by 120 volts times 100, which equals 9.9%. In this example, the voltage drop exceeds the recommended limit of 3% for branch circuits. To reduce the voltage drop, you could increase the size of the conductors to number 10 American wire gauge, which has a lower impedance, or shorten the length of the circuit. Round fault circuit interrupters, or GFCIs, are essential safety devices that protect people from electric shock. GFCIs work by monitoring the current flowing through a circuit and detecting any imbalance between the hot and neutral conductors. If an imbalance is detected, the GFCI quickly trips the circuit, interrupting the flow of electricity and preventing a potentially fatal electric shock. The NEC requires GFCIs to be installed in various locations, including bathrooms, kitchens, garages, outdoor areas, and construction sites. In bathrooms, GFCIs are required for all receptacle outlets located within 6 feet of a sink or shower. In kitchens, GFCIs are required for all receptacle outlets serving countertop surfaces. In garages, GFCIs are required for all 120-volt, 15-amp, and 20-amp receptacle outlets. Outdoor areas, GFCIs are required for all receptacle outlets that are readily accessible. On construction sites, GFCIs are required for all 120-volt, 15-amp, and 20-amp receptacle outlets that are not part of the permanent wiring of the building. Arc fault circuit interrupters, or size, are another type of safety device that protects against electrical fires. A size works by detecting arc faults, which are dangerous electrical conditions that can cause fires. Arc faults can occur when there is a break or weakening in the insulation of a wire, causing electricity to arc across the gap. This arcing can generate a significant amount of heat, which can ignite nearby combustible materials and start a fire. The NEC requires a size to be installed in various locations, including bedrooms, living rooms, dining rooms, and family rooms. In general, a size are required for all 120 volt, 15 amp and 20 amp branch circuits that supply these areas. When selecting GFCIs and their size, be sure to choose devices that are listed and labeled by a recognized testing laboratory such as Underwriters Laboratories or ETL Intertech. These devices have been tested and certified to meet the applicable safety standards. Be sure to follow the manufacturer's instructions when installing GFCIs and size. These devices must be properly wired and grounded to function correctly. Test GFCIs and size regularly to ensure that they are working properly. Press the test button on the device to simulate a fault condition. If the device does not trip, it should be replaced immediately. Surge protective devices, or SPDs, protect electrical equipment from voltage surges, which are sudden increases in voltage that can damage or destroy sensitive electronic components. Voltage surges can be caused by lightning strikes, power outages, or the switching of electrical equipment. SPD work by diverting excess voltage away from the protected equipment and safely dissipating it to ground. The NEC recommends that SPD be installed at the service entrance of a building to protect the entire electrical system from voltage surges. SPD can also be installed at individual pieces of equipment to provide additional protection. When selecting SPD, be sure to choose devices that are rated for the voltage and current of the electrical system. The SPD should also have a sufficient surge current capacity to handle the anticipated surge events. Follow the manufacturer's instructions when installing SPD. These devices must be properly wired and grounded to function correctly. Regularly inspect SPD to ensure that they are working properly. Some SPD have indicator lights that show whether the device is still providing protection. If the indicator light is off, the SPD should be replaced immediately. Electrical permits are typically required for most electrical work, including new installations, modifications, and repairs. The electrical permits ensure that the work is performed in accordance with applicable codes and standards and that it is inspected by a qualified electrical inspector. The process for obtaining an electrical permit typically involves submitting an application to the local building department, providing a description of the proposed work, and paying a permit fee. Once the permit is issued, the work can begin. After the work is completed, an electrical inspector will inspect the installation to ensure that it complies with all applicable codes and standards. If the installation passes inspection, the inspector will issue a certificate of approval. Working without an electrical permit can result in fines, penalties, and delays. It can also create a dangerous situation as the electrical installation may not be safe or compliant with applicable codes. Be sure to obtain all necessary electrical permits before starting any electrical work. Consulting with a licensed electrician can be beneficial for complex electrical projects. A licensed electrician has the knowledge, skills, and experience to perform electrical work safely and in accordance with applicable codes and standards. A licensed electrician can help you design the electrical system, select the appropriate materials and equipment, and install the wiring and devices correctly. A licensed electrician can also help you obtain the necessary electrical permits and pass the electrical inspection. The cost of hiring a licensed electrician will vary depending on the scope of the project and the electrician's hourly rate. However, the cost is often worth it, as it can help you avoid costly mistakes, ensure that the electrical system is safe and reliable, and comply with all applicable codes and standards. When selecting a licensed electrician, be sure to check their credentials and references. Make sure that the electrician is licensed and insured and that they have a good reputation. Get a written estimate from the electrician before starting any work. The estimate should include a detailed description of the work to be performed, the materials to be used, and the labor charges. Discuss the project with the electrician and ask any questions you may have. Make sure that you are comfortable with the electrician and that you understand the scope of the work to be performed. Consider the specific requirements for the steel building. Steel buildings often have unique electrical needs due to their construction and intended use. For example, steel buildings may require special grounding and bonding to prevent electrical hazards. Steel buildings may also require explosion-proof wiring and equipment if they are used to store or handle flammable materials. The NEC provides specific requirements for electrical installations in steel buildings in Article 513. These requirements cover the grounding, bonding, wiring methods, and equipment that must be used in steel buildings. Be sure to consult with a licensed electrician to ensure that the electrical installation in the steel building complies with all applicable codes and standards. Also, consider the future expansion. When designing the electrical system for the 1 acre lot, it is important to consider the possibility of future expansion. For example, you may want to add additional buildings, equipment, or appliances in the future. To accommodate future expansion, you should install a service entrance and electrical panels that are large enough to handle the anticipated load. You should also run conduit to all potential future building sites so that it will be easier to add electrical service in the future.